Okay, this is unit 8.2, and I'm adding a little bit information about Pythagorean triples in this unit. Pythagorean triple is just a name for a set of three numbers, A, B, C, such that these three numbers fit into the Pythagorean theorem. So a squared plus b squared has to equal 3 squared. So one of the examples is right here. If you do 3 squared plus 4 squared, you have 9 plus 16, which gives you 25, and that's 5 squared, right? Those are just a set of three numbers, so they're triples that are easy to remember. Here are some other examples, 5, 12, and 13. 5 squared plus 12 squared is 25 plus 144, which comes out to be 169, and that happens to be 13 squared. And 9 squared plus 40 squared, which is 81 plus 1600. So you should have 1681. If you square root of that, that gives you 41 squared. So another thing you need to be aware of is multiples of Pythagorean theorem, of Pythagorean triples, of P triples work too. So my favorite is 3, 4, 5. And then if I just multiply them by 2, 6 and 8, and I know the third side, which is the hypotenuse, has to be 10. So let's double check on that. 6 squared plus 8 squared, that's 36 plus 64, which becomes 100, and which equals 10 squared, right? So I can multiply the 3, 4, 5 by 5. So 3 times 5 is 15, 4 times 5 is 20, 5 times 5 is 25, and this would give me a right triangle as well. So the multiples of Pythagorean triples work as well. Finally, this is the list of first few of them. I think we really expect you to recognize probably this 4 instantly, and definitely these 2 are the most obvious. And then the rest of it, you can use your calculators. We don't expect you to memorize this table at all. So the first 4 or 5 will help you speed up with your calculations a lot. So again, I don't place a lot of emphasis on this. This is really just an old trick in the old SAT. With the new SAT, I'm not even sure they place much emphasis on that because some of it requires memorization. And if you understand Pythagorean theorem, obviously, as long as you're given 2 numbers, you can calculate the third side, right? So let's move on to special right triangles. This is the meat of 8.2. We're going to look at 2 special right triangles. One is 45, 45, 90 degrees, and that is an isosceles right triangle. So in this case, if I let my leg equal x, the other leg has to equal x as well, and then my hypotenuse becomes x squared plus x squared square root, and I should have x root 2. So there's a little bit of square root involved in this. Again, if you need to review square root, make sure that you do it outside of before you come to class today, because you have to be fluent in this. Now find the value of each missing variable. If I have 45 in one, I have 90, I know this one has to be 45 degrees. Immediately this side, x has to equal 8. And if x is 8, y, without calculating it, I can use this theorem or this property to know that the other side, the y, the hypotenuse, is x root 2, which is 8 root 2. Right? Same thing here. I would have 45 degrees here. So y would be 25. X would be 25 root 2. So literally, it's one leg multiplied by root 2 would give you the hypotenuse. So over here is 45 So now my x and y are the same, but my hypotenuse is given. So if my hypotenuse is always 1 leg times root 2, so my x would be 19 over root 2. Here, how do you simplify this? A root cannot be, customarily cannot be in the denominator. So I just need to multiply a root 2 over 2 so that that 2 will come out. So this would come out, and on top is 19 root 2. So that's my answer there. So both of them is 19 root 2 over 2 is the answer. Okay? Let's look at number 8. Number 8, I have the longer leg at 20. So the shorter leg is y. So we know and the hypotenuse is x. So we know the shorter leg, which is y, is multiplied by root 3 would give me 20. So 20 is root 3. Y equals 20 over root 3. And if I want to get rid of that root 3 in the denominator, I just need to multiply that. So I have 20 root 3 on top and 3 at the bottom. 20 root 3 over 3. That's y, right? And then we know that the hypotenuse will be twice as long, so that's multiplied by 2. So I would have 40 root 3 divided by 3. So that's how you do it with these type of problems. I'm gonna do another one. Maybe I'll do number 9. Let's look at number 9. I have the shorter leg. I have 30 degrees facing the shorter leg, and the hypotenuse I don't know, but I know the longer leg. So again, the shorter leg multiplied by root 3 equals my longer leg, which is 9 root 3. So therefore my x is 9. If my x is 9, then the thing is the hypotenuse is twice as long. So it's 9 times 2. That's 18. Okay, so finish the rest of the problem, and the page behind this is a mixed practice that includes both 45, 45, 90 degrees, 90-degree triangles, as well as 30, 60, 90-degree special right triangles. And bring your questions back to the classroom, guys. And I look forward to seeing you there. Bye.